Okay, let's move further with one more interesting example. Now we need to obtain limit of log x minus log 2 upon x minus 2 as x approaches 2. Again, let us try and simplify. At the most, what we could do is we could use the law of logarithm. That is, log a minus log b is what? Log of a upon b. So let us bring it to that form. So we have limit as x approaches 2 log of x upon 2 upon x minus 2. So still the denominator value is 0, right? So we tried and simplified, but nothing could work out. This cannot be brought in any of the standard forms also. So again, the method left out is substitution. So what we do is, again we substitute x, okay, as what? A plus h. Now a is the approaching value. So you put x equal to 2 plus h, and hence we could say as x approaches 2, h would approach 0. So if you observe in the function we have two x terms, one x over here and one x over here. So both these x terms would be replaced by what? 2 plus h, and x approaches 2 will be replaced by h approaching 0. So therefore we could say, therefore we get limit of, now the first change would be h approaches 0. Then the log term, log of, now x has become 2 plus h. So remove this x and put 2 plus h divided by 2. Again in the denominator, remove this x and put 2 plus h. So you have 2 plus h and this minus 2 out here, right? So this 2 gets cancelled here. So we are left with limit as h approaches 0 log of, now we could separate this 2. So we have 2 divided by 2 plus h divided by 2, the whole thing divided by h. So finally we get limit as h approaches 0 log of 1 plus h upon 2 divided by h. Now this could be compared with one of the standard limits. If you remember, limit of log of 1 plus x upon x as x approaches 0, the value of this limit is 1. The condition is this x term, right? Both the terms must be identical. Now here we have h upon 2. So we need to have h upon 2 in the denominator as well. So we'll multiply and divide by 2 in the denominator. So finally what we get here is limit as h approaches 0 log of 1 plus h by 2. Again in the denominator h upon 2, and we balance it with 2. Correct? Now this 2 is extra and it's a constant, so we could take it outside. So when you take this 2 outside, it's in the denominator, right? So it becomes half. So we have 1 upon 2 limit as h approaches 0 log of 1 plus h by 2 divided by h by 2. Now see, it is exactly in this form, right? The x terms are matching, x approaches 0, but instead of x you have h over here. So we have the exact identical h terms here. H is approaching 0, so the value of this limit could be considered as 1. So we have half into 1. So the final answer is half. So we tried and simplified. So we reached to this step. Log a minus log b is log of a upon b. But nothing further could be done. No standard limit could be applied here. So the only option left was substitution. So we use the technique of substitution. You put x as 2 plus h. Right? So replace these two x terms by 2 plus h. And replace x approaches 2 by h approaching 0. You simplify. you reach to this step. Now this could be brought in this standard form, right? But the x terms over here must match. So here we have h by 2. So we need to have h by 2 in the denominator as well. So you multiply and divide by 2. Now this 2 is extra and it's a constant in the denominator, right? So we take it outside. So you have half over here. Half into, and then you have a standard limit of this form, the value of which is 1. So half into 1. So the final answer is half.